derivatives of inverse trig functions. So we know our 6 derivatives of trig functions. This is the inverse trig function. So what's the derivative of sine inverse? Okay, sine inverse being the one that's the second function on your calculator, right? Yeah. That's the one we're looking at here.
Do we have to memorize these trigs?
Yes.
No, not necessarily. Just hang with me. Hang with me. Okay. Now, and I'm going to tell you guys, we're going to go through 6 trig functions, or we're going to go through 3, I guess, but there are 6 inverse trig functions. But in terms of memorization, I'm trying to remember, is it sine and tangent are the 2 they suggest to memorize? And really, once you know sine, you know cosine, because there's only one sign difference. So, okay. We're going to talk about derivatives of inverse trig functions and we're going to do this first off using the ratios of a right triangle and implicit differentiation. Once we have this, we'll have the rules, okay? But this is kind of looking at the connections here. So, it asks us to use the Pythagorean theorem, properties of right triangle trigonometry, and implicit differentiation to derive the inverse trig function formulas. So, given the equation y equals sine inverse of x, they're asking us to find the derivative of sine inverse x. Now, okay, start basic with me here. Sine inverse. Inverse functions. Inverse functions in general do what? Inverse functions take your x and your y and switch them, yes? Sine inverse is no different. Sine inverse takes my x and my y from sine and switches them. So if this is y equals sine inverse x, except it's not going to be sine inverse, it's going to be sine y equals x. Okay? Now, with that in mind, we found the inverse. We're trying to take the derivative. Well, we can't solve for y. Okay? The only way you can solve for y here is go back to the inverse. And we don't know the derivative of the inverse yet. So we're going to use our implicit differentiation. Okay? So we're going to take sine y and x, and we're going to take the derivative of both sides. So I'm going to say d dx in front of each of these. Means I'm taking the derivative of both sides of my equation with respect to x. Now, okay, on the left, what's the derivative of sine of something? Cosine of something, so it's going to be cosine of y. Now, times the derivative of something. Since we're doing the derivative of y, but with respect to x, what do we need to say this is going to be times by? dy dx. Thus, the implicit differentiation aspect, okay? On the right, what's the derivative of x? 1. And with respect to x, it's just 1. Okay, you could say times dx if you want, but you don't need it. Okay, so now we're going to solve this for dy dx. dy dx is going to be equivalent to 1 over cosine of y. Now, this is where our right triangles are going to come in. Okay? Because to give our final rule, we're not going to leave it as the derivative of sine inverse is 1 over cosine y. We need it in terms of x. So this is where this comes out. So, how do I want to start this? My original problem, here, let's look at it over here. This original problem right here, yes, was sine of y equals x, which is x over 1, correct? So here's angle y. Sine of y. Sine is opposite over hypotenuse. So right here, this is x is the hypotenuse, or opposite, excuse me, 1 is the hypotenuse, yes? So thus, x over 1. Where does square root of 1 minus x squared come from? X squared plus something squared equals 1 squared. What am I doing here? I'm doing like a Pythagorean theorem. I think in my notes I have this as, if you think about this side as side B. X squared plus b squared equals 1 squared. Solve this. So b squared is going to be 1 minus x squared. And what is b? The square root of 1 minus x squared. So they already did the Pythagorean theorem for you. But based on the original statement that sine of y is equal to x over 1, then you can find that third side. Okay? Now, we're looking here. We need to know cosine of y, yes? We need to do 1 over cosine y. So right now, let's just figure out what is cosine of y. Cosine of y, yeah, it's adjacent over hypotenuse. So square root of 1 minus x squared over 1, which is just square root of 1 minus x squared, yes? Okay, are you following this? We just found cosine y to equal the square root of 1 minus x squared. So, dy dx is equivalent to 1 divided by what? Square root of 1 minus x squared. Okay? That is your answer. That is the derivative of sine inverse of x. Okay? Now, if you turn to the next page, just for a moment, the first top left box, it says d dx, it says arc sine. Do you guys remember sine inverse? Another way to say it is arc sine. Okay. I'm trying to think. I did introduce it in pre-calc. Okay? So sine inverse, arc sine, same thing. But notice, it is u prime over square root of 1 minus u squared. Well, square root of 1 minus u squared, that's our square root of 1 minus x squared. They say u prime because that represents the chain rule when you have to do the derivative of the inside. Okay? So that's your derivative right there. Okay? Now, let's try and do the same thing with b and c. Okay? So b, given that y is cosine inverse of x, find the derivative of cosine inverse. Okay. Y equals cosine inverse of x. So cosine of what? Y equals x. True statement? It's the inverse. So x and y, your variable, your input and output are switched. We're going to take the derivative of both sides with respect to x. So we're going to do the derivative of cosine y and the derivative of x. What is the derivative of cosine of something? Okay. Negative sine of something times, what's the derivative of something? So what's the derivative of y? Okay, it's 1 and then times dy dx because it's with respect to x. On the right, what's the derivative of x? 1. Now, if I solve this for dy dx, dy dx is going to be equal to what? Okay. And I wrote mine as the negative of 1 over sine y. Doesn't really matter where the negative is as long as it's there somewhere. Okay. So, my original statement was cosine of y is equal to x, which is x over 1. Notice what's set up. Here's angle y. Cosine is adjacent over hypotenuse. How are they going to get this third side here? That's your Pythagorean theorem,
Yeah.
right? Okay, so the idea that it's x squared plus, I'm going to say b squared again, equals 1 squared. In other words, I'm using b for this side here. So if I solve that, b squared is 1 minus x squared, and b is the square root of 1 minus x squared again. Okay. We need to know on this one what sine y is. Sine of y is what? Yeah. Opposite over hypotenuse, if you will. The square root of 1 minus x squared over 1, which is just square root of 1 minus x squared. Is that piece familiar? It is. So, what do we know now? Dy dx is negative of 1 divided by square root of 1 minus x squared. And this is the derivative of cosine inverse. What's the difference between the derivative of sine inverse and cosine inverse?
Negative.
A negative sign, yes? So if you can memorize sine, all you have to know is that cosine is the opposite. Just like the derivatives of sine and cosine are each other, just one of them's the opposite. Same idea there. Okay, C. I don't think it's too bad, is it? I don't think so. Okay. So, y equals tan inverse x. So, inverse is going to be what? Tangent of y equals x. And we're going to do the derivative of both sides with respect to x. So, d dx of tangent y is going to equal d dx of x. Oh, is he racking his brain here?
Shoot.
The derivative of tangent of something.
Oh, I know. Secant squared.
Is secant squared.
Yeah, there we go.
Secant squared y times the derivative of y, which is dy dx, equals the derivative of x, which is 1. This part is kind of the same old, isn't it? Dy dx is going to be 1 divided by secant squared y. Did I use that form? I did. Okay. Okay, so tangent of y is equal to x over 1. So here's y. Tangent is opposite over, nope. I didn't say it, but I started to write it. So opposite over adjacent. So there we have x over 1. So if we set up x squared plus 1 squared equals c squared. Well, all you have to do is square root, right? C is the square root of x squared plus 1. They have it as 1 plus x squared, I guess. Okay? Convinced? So do you have to memorize the triangles, Aiden? No, you do not. Okay? Now, we need to know the secant squared.
1 over cosine squared.
We can go that route. 1 over cosine squared. So 1 over, what's cosine going to be here?
1 over
But keep in mind it's cosine squared, so that's also going to be squared. Looks ugly, but give it a moment. 1 divided by 1 squared is 1. What's the square root squared? It's the inside. So now I have 1 divided by 1 over 1 plus x squared, which is 1 divided by is 1 times, oh, wrong button. 1 divided by that fraction is 1 times the reciprocal, yes? So it's 1 times 1 plus x squared over 1. It's all just going to be 1 plus x squared. So secant squared y became 1 plus x squared. So dy dx is 1 over 1 plus x squared. No square root in this one. This is the derivative of tangent inverse.
That's how we can.
Okay. Now, when you look at the next page, this summarizes the rules, yes? Now, keep in mind, like that one we just did, we had the derivative of tangent inverse, which this is the same thing as saying the derivative of, that's the same thing. Oh, except I shouldn't write, well, okay. You know, they use arctan. That's the same thing as saying tan to negative 1, tan inverse, okay? So just realize, all of these say arc, it's inverse, okay? Be flexible, go back and forth here. Notice the one we just came up with, it was 1 over 1 plus u squared. What's this u prime stand for? Just if there's a chain rule to put there, okay? So in all of these, this is really like a 1 in the numerator, right? There's a, you know, it's like a 1 in the numerator if that helps you think about it. And then that u prime just represents the chain rule. So I'm going to say u prime represents chain rule. So don't stress about that. Just if there's a chain rule, do it. Okay. We're going to try and do at least a couple of these, depending on what, you know, 1 or 2, depending on time allows, just because I want you guys to see a little bit of it. And again, I'll probably reteach on Monday too, would be my guess, but I don't know how I want to handle this. Okay. He's protecting his head and neck and...
No, it's awesome.
Okay, so sine inverse of 5x. With this in mind, we're being asked to differentiate. So we're being asked to find dy dx. Trying to decide how I want to explain this. So sine inverse of 5x. Keep in mind, basically 5x is in the place of what? U, yes? Okay, so for a sidebar, I want you guys to think about u is basically a 5x. With that in mind, what is my rule for sine inverse? What we learned on the other page basically was what? 1 over the square root, 1 minus, and it was, quote, x squared, yes? Or in this case, u squared. What is in that place of u right there?
5.
Not just 5, but
Sorry.
5x. So this is going to be 1 minus that quantity squared. So 1 minus the 5x squared. Now, okay, so that's because it's u squared. So whatever this is, square it. Times. This is my chain rule part. What part have I not done up here? I haven't done the u prime. So times the derivative of the inside. What's the derivative of 5x? So times 5. Right. So we're going to clean it up. I am going to put, and so you can see why they have u prime on top, yes? I'm trying to get us there. Baby steps. Here's what I'm trying for. 5 over the square root of 1 minus 25x squared is what I'm going to write that as. Okay? So it's just the idea that if u is 5x, then we usually say du, or u prime, is 5. Also the fact that if u is 5x, u squared is 5x squared, or in other words, the 25x squared. Those are all kind of the pieces we had to talk about there. Okay? Let's try B. We'll see. Okay. Tan inverse. So we're using our tan inverse rule. Here's what I'm going to ask you. Not that you have to write this out, but we're beginners. What is in the place of u? Basically, what is the inside of the arctan, or the tan inverse?
2x plus 1.
Not even just 2x plus 1, but square root of 2x plus 1. That whole inside of tan inverse is your u. Okay? Now, what's my rule for tan inverse? It's u prime, which for right now, I'm just going to say 1. We'll do the chain rule here in a moment. Over 1 plus u squared. So what am I going to do? I'm going to do the square root of 2x plus 1 squared. Times. Why am I saying times? Now we've got to do chain rule. I didn't say it was a fun chain rule, did I?
No.
This is 2x plus 1 to the 1/2, yes? So if we do the derivative, I'm just going to even call it u prime for right now. What are we doing? 1/2 2x plus 1 to the negative 1/2.
Times 2.
Good. Why do you do times 2?
Just gotta do the inside too.
Because you got to do the inside of that.
Help chain rule.
Now, what's the nice part? 1/2 and 2 cancel. So this is really just 2x plus 1 to the negative 1/2, or 1 over the square root of 2x plus 1, if you will. Does that make sense? And what is this I'm multiplying over here? 1 over the square root of 2x plus 1. Now, clean this up real quick. 1 plus, what happens when you square the square root? It's 2x plus 1. We're still times 1 over the square root of 2x plus 1. dy dx. Gosh dang it, I don't have time. On top, 1 times 1 is? 1. On bottom, the first part, 1 plus 2x plus 1 is 2x plus 2 times the square root of 2x plus 1. That's it. The only other thing you could do, my answer key in the 2x plus 2, it has a 2 factored out. And it says 2 times x plus 1. Okay. I'm not 100% sure of my plan for tomorrow. I hate to say that, but
I will be here tonight.
I know. I may go ahead and teach, and I may just teach again Monday.
Okay.
You know? But if I teach tomorrow, there'll be a video, so Augie and Tate, if you guys want to go look at that, it wouldn't hurt. And then I can still reteach, even if, you know, we'll see.